This is the topic that we covered in class on the day before break, so I want to make sure that we feel comfortable solving problems. And once again, we're going to use conservation momentum. So we have M1. We'll call this, I should add something to this. So we have a 0.025 kilogram bullet fired from a gun with a speed of 230 meters per second, and we want to know the recoil speed of the gun. So we should be really clear on how we define this problem. It says a 0.25 kilogram bullet is fired from a gun. Both start at rest. So we should say that U1 equals 0 and V1 equals 0. This will be M1, this will be M2, but then this will be this will be V subscript 1, the speed of the bullet, and V2, the recoil speed of the gun, is our unknown. So if I were to draw this, here's a bullet, here's a gun, they are together. This is the before, and then afterwards what we're going to see is the gun actually moves backwards as the gun moves forwards. So we'll set this up as M1U1 plus M2U2 equals M1V1 plus M2V2. That's 0.025 times 0 plus 9 times 0. It's a pretty heavy gun, an 18-pound gun. I don't know if that's, maybe, I don't know. Equals 0.025 times 230 equals 9 times V2. So we're going to end up getting 0 equals, I'll grab my calculator here. So 930 times 0.025 is going to give us 23.25 plus 9V2. And when we solve, V2 is going to equal negative 2.58 meters per second. That could definitely pack quite a wallop. All right, here we go. Next question. A 91 kilogram man lying on a surface of negligible friction shoves this stone away from himself. He gives it a certain speed. We want to know the speed the man acquires as a result. So once again, here we start like this with U2 equals 0 and U1 equals 0. And what's going to happen is he's going to push the stone away. He'll go this way, and the stone goes the other way with a speed of 4 meters per second. And so we set up our equation. So this is M1, this is M2, U1 and U2 both equal 0. And his speed is 4 meters per second. And we want to know what the speed of the stone is going to be. Sorry, this is the speed of the stone. We want to know what the speed of the man will be. So, M1U1 plus M2U2 equals M1V1 plus M2V2. 91 times 0 plus 0.68 times 0 equals 91 times an unknown V plus 0.068 times 4. And that's going to give us V1 equal to times 4 divided by 91 let me just double check that one more time. 0.068 times 4 divided by 91. That's going to get me negative 0.003 meters per second. So 3 millimeters a second. I'm just going to double check that one last time. 0.068 times 4 divided by 91. Okay, that's it. All right, now, number 3. A 0.035 kilogram bullet strikes a stationary wooden block and embeds itself in the block. The block and the bullet fly off together 8.6 meters per second, and we want to know the original velocity of the bullet. So, we have this bullet going like this. So what we know is U1 is unknown. U2 of the block is 0. And then here's the interesting part. The block and the bullet go off together. So we have V1 and V2 equal each other, and they're both unknown. So let's set this up. 0.035 times V1 plus 5 times 0 equals 0.035 times 8.6 plus 5 times 8.6. So we're getting 0.035 times V1 equals, let's figure out what this right side is. We'll take 0.035 times 8.6 plus 5 times 8.6. And that's going to give us 43.301. So when we isolate V1, we're getting, that's pretty fast, 1,237 meters per second. I actually think that is a realistic speed for a bullet. I can't remember. I can say this much, it's faster than the speed of sound, which means it hits the target before you actually hear the gunshot or the rifle shot. So that's kind of interesting. All right. Next, we have a green ball and a red one. They hit, they collide, and things happen. So what I want to do with a problem like this is actually label things carefully. So with green, this is M1, this is U1, this is M2, this is U2, and this ends up being V1. So what we want to solve for is V2. So let's go ahead and set this up as best as we can. So we have M1 U1, M1 V1 plus, we'll set an equal sign here, plus M2 U2, M2 V2, and we're going to just put in our numbers. So we have 0.01 times 0.2 plus 0.02 times 0.1, and that's going to equal, now let's just double check something. It's still moving in its original direction, so we don't change the sign of anything. That can happen sometimes, so we'll say 0.01 times 0.08 plus 0.02 times the unknown v2. And now I'm just going to work in one color to get our unknowns. So 0.01 times 0.2 plus 0.02 times 0.1. So I'm getting here, so 0.01 times 0.2 plus 0.1 times 0.2 gives me, yes, 0.004 equals 0. And let's just be careful with this, 0.01 times 0.08 gives me 0. Careful, 1, 2, 3 zeros, and then the 8, plus 0.02 times our unknown v2. When I simplify, that's going to be 0.0032 equals 0.02 times v2, and that is going to give us a v2 equal to 0.16 meters per second. All right. So those are our conservation of momentum problems. Actually, you know what? We'll do number 5 before we move on. So for number 5, we will say a 7. And you know what? I'm going to try to set this one up without doing every little step. M1U1 plus M2U2 equals M1V1 plus M2V2. Now they travel together, so I'm just going to say V1 equals V2, and that equals just this final velocity, V, that I'm going to solve for. So keeping that in mind, we're going to say 700 traveling at 20 meters per second collides with a 1,400 kilogram truck completely at rest. And then we're going to have the 700 car and the 1,400 kilogram truck traveling at the same final speed. So when we finally put all this together, we will solve and get 700 times 20 divided by 2100 gives us 6.67 meters per second. All right, in the next video, we will take a look at the momentum impulse review.